How's it going, everyone? Welcome, Julio Gonzalez again. In today's, we're gonna talk about the React Performance, which is a course taught by Steve Keeney. But we're gonna focus our attention is on looking at the React Dev Docs, specifically the guide or the learn sections, as a way to walk through each one of those topics and be able to describe them in the most effective and efficient and succinct possible way. Why is that? As a way to not only put at practice my technical communications, but also understand is the finicky aspect of working with React by looking at the basics, and then how from there we can scale that up to build now not only performing React components, which is what this course is all about, but also to write production ready React application. So because this course is taught by Steve Keeney. Oh my god, sorry. He's the head front engineer at Temporal, which is a durable execution platform. You can think of this like some sort of Kubernetes or orchestration systems to cover some business use cases, right? And as I mentioned before, that we know what is the goal of this course, and that is looking now at a specific goal, which is, all right, now how can we organize our components hierarchy in a way that makes our React components and our app perform the most quickly way possible, and also how can we use this memoized strategy as a way to say which components do we want to React call them. Also, how can we now load or React components later on using the React built-in tools, as a way to understand now how is the concurrency in React 18, which is using this low priority re-rendering or low priority rendering modes like use the first and use transitions. And lastly, now build a toolset that allows to not only identify its React performance issues, but also come up with some best practice when that thing happen. And that is by using is pretty much like a big knot. When you have when you now pick the right threads and you're starting to apply the things that you already know over and over and over until you you're not that tight. So sorry. So the core structure of this is we got the introduction, which is something that we're gonna quickly and briefly go over that. The React rendering, which is what we're gonna focus our attention today, and then reducing rendering, context, and suspense and transition. So this is the introduction from Steve Keeney as a way to say, hey, the whole point of this course is to understand now how React works behind the scenes. Eventually, you will need to learn how that works as a way to, when it comes to actually detect some performance issues, you build a tool set that then you can come up with some of solutions, aka best practice, to help your React applications to work performantly as possible. So, because initially you can start to joking about that this is something that we need to refactor with your college and kind of thing, until that is no longer a joke. So the idea here is that by looking at these techniques, how can we now apply them over and over and over, regardless the size of your app. So that's one of the things, and also something that a lot of these people, or when you're going into a particular company to actually help them to build this, it's like, hey, how can we gonna do this? How am I going to do this? So the value proposition of the performance is to say it is better, it is not doing things is faster than uh, doing it. This is also you can apply to your life as a way to prioritize things. What are the things that you need to prioritize first, and then focus on that, okay? Or not focus on the things that are not priority, okay? So not doing stuff is way faster than doing it, and there's some corollaries to that. Doing things after is faster than doing it now. So with that, and also looking at what are the tool set, broadly speaking, that we need to know, especially to diagnose this React issues performance and how we can come up with a solutions. First is look at the React app on productions is using the production build. Because the development production is 4 times heavier than the prod. Okay, then take a look at now the component hierarchy. Okay, in the state, so you can start from there. Remember that at the end of the day, you must have a problem to actually solve that. So the idea here is that, hey, do we really have a performance issue in our React applications? If it is, all right. Where? Then you also look at the memoization strategy. Which components actually you are telling to React to say, hey, no, I don't want you to call this, okay? And it's important to put those components where you are memoizing, okay, where you are not calling them, or that you are calling is based on a specific dependencies, to put them not only top or higher in your render tree, in fact put them at the bottom of that. Because what happens is that if you need to perform some sort of cascade effects, then that actually can hurt those re-rendering. If that is what you want, if that is the case. If the other thing that you can do is that, well, let's going to now load things later. Let's going to use the suspend as a way to say, hey, once this is done, I want you to now load this component. And ultimately, if you're in a pickle, using the transition API. So first thing first, we need to understand and be able to describe is the React, and that is the React rendering cycles. So before doing that, we need to actually, what we're gonna do is to describe here what are we gonna do, okay? And that is looking at the Learn React and be able to describe this as a story. How do we get here, and what React offer us? How does it work, and how can allow us to write now production grade React application? Because at the end of the day, React is this framework for building UI, user interface. So how can we now describe those user interface? Is by using by looking is the way how React allows to do that. How can we import and export components? Also, how can we now define our components as a JSX, as a way to now enable JavaScript in our template, and how you can now let it on, which is something like you put it here. The rules of the JSX is that exactly also the rules of the JSX is that you must return always a single root element, okay? Close all the tags, okay? In camel case, almost, not always, almost of the things. So by understanding is the JSX, and its rules, as well as how can we now pass props to our components, how can we now conditionally render components, and after all, what we're returning is just GSX, which is not an instance. In fact, is like a blueprint, something that we're going to see now that in depth. How can we now render in lists? Why it's important to understand is that pure functions are the way of how now React allows us to stop computations in a safely manner. Okay, so for example, if you need to render your components in a tree data structure, something we're going to talk about that. How now, for example, when React needs to re-render the component, a new state, a new update, hey, how now with the React, how now by having pure React components, it allows us is to stop the computations safely. Also, when you want to run now these React components or these functions, because at the end of the day, they are just JavaScript function, they create their own function execution context with their own threads and local memory, all right, and then evaluate all of that until it returns that. So, because this is our JavaScript functions, and now how can we is define is the JavaScript as well as our the template. So creating these functions in a pure state, meaning that it doesn't mutate anything outside of the JavaScript functions, which is receive the inputs and always generate is the same output. This is a concept comes from functional programming, okay? But the idea of the benefit of this approach in the context of React is that it allows us to run these components regardless the environment, whether it's a server or the client, and we can also is catch our results. And I think this is one of the key components, especially as you going down into your journey, to understand now how, for example, Next.js is working behind the scenes with the server component, which is a topic that we're going to talk about that later. But the idea of looking at the understanding is the purity aspect of these React components is because it allows those aspects. Yeah, it allows those aspects for. Okay. It allows those aspects. First, we can run these functions regardless the environment, okay? And with that we can catch our results. We can also is now stop the computation of a React component in a safely manner. And I think there is another and you can improve performance by skipping rendering. Oh, performance. Okay. The first is the flexibility that these purity functions provide us completely. The flexibility. Okay. The second is the performance, because now we can indicate to these components, hey, I want you to skip rendering. I want you to skip calling. I want to React skipping calling this function exactly. You can improve performance by skipping rendering components whose input have not changed. Okay, and this is safe because pure functions always return the same results, so they are safe to catch as well. Exactly. Okay. flexibility, because now we can run our React components in different environments. The server, as long as it runs JavaScript, the server, the browser, the worker as well. So any environment, any JavaScript environment, we can now run our components. Also, we can skip, in the context of React, we can skip renderings, which after all, it results, since we are now pure, since we got pure functions, we always get the same input and return the same output. Okay, so it is safe to catch them. And last but not least is that it is safe to stop calculations when you are in the middle of some data change. So for example, in the data, but this is interesting. This is very, very interesting. The reason why do we care about purity in React? For the flexibility it provides, for the performance and catching, okay, when you're going to serve that content to the users, and for the safety of stopping a computation, and for the safety of stopping a calculation at any time without performing any side effects. Okay, without leaving any side effects. Okay, so every new React feature we are building take advantage of purity, from data fetching to animations to performance. Keeping components pure, you unlock the power of React padding. But that's one of the benefit of using the React component. And also, as a way to describe is, why do we do the thing that we do? Why do we actually need to write this component in this particular way? Oh, because it allows flexibility. We can run these components in any JavaScript environment, whether it's on the server, on the client, on worker. Also, it allows us to skipping rendering for performance reason, or for catching results, because at the end of the day, giving this particular input will provide us, or will return us the same output, so we can catch that. Useful when you're going to serve that content from the server to the client. And also when some data change in the middle of a rendering, so you can stop that. Okay, let's say you're actually passing is down data, you can stop that in a secure way. And by looking is that this data handler, this data passing, is now part of the render tree, where now this render tree and the tree dependency is the way how React see things. In the context of the render tree is how React organizes our components in a tree data structure. And in the case of passing logic, relevant logic to this component as a way to provide some interactivity, okay, or some utility functions, how can we now have is a tree dependencies? So the render tree, once you understand that, allows us to see how is React not only render components, but how can we optimize is that for performance issue, and also how our data flow go through. And the tree dependency is that which code are we calling, and which one of them can we call them later on, so we can defer that as a way to when the user requests a page, now we send is the bare minimum necessary code for that. All right. It's like, all right. Okay. Good. Cool. All right. Interesting. That's interesting. Totally. So now when we understand is how can we describe our UI and how React now represents those UI for us, Now we need to know how can we add interactivity to that, and that is by connecting is the handlers to our JavaScript. Pretty much is like using is the way of how now, or this synthetic event that actually React expose based on the done event or the event interface. Okay, and how, by looking now at the way of how can we now pass data to add this interactivity, because at the end of the day, for example, if you go to Stripe or Wise or any of this fintech, you want to know your balance accounts. For example, hey, you want to see your transaction history. All right. So to pass down data here, React have this state, which is a component memory, a component's memory. So here, by looking at this state, now we also use is the use state as a way to now trigger is rendering. Why is that? For example, if the user now, or when you're adding interactivity to this component, if the user, for example, wants to send $10 to, you want to send $10 to your mom, okay? You want to now see that transaction actually happened, and you want to see something here. You want now is to rendering this. So the way of how can we now update the state of a UI is by setting is the state. And this is something interesting, because when you set the state, you might think that you're going to have is the state value or the variable state at that moment, but but you're gonna get is the state variable. So after you trigger is the state, you're gonna get that state snapshot in the next render. So what is this rendering mechanism? Is the way of how now React detect, renders, aka call your React components, okay, and then commit those changes to the DOM. So it is triggered by or the initial render, or by a component states updates, or any of its ancestors. And when that happens, you say, okay, I'm going now to render this, which is I'm going to call this, I'm going to call the React components that trigger that state updates, which can be at the initial render, okay, that adding all of this, that calling all of these elements, or it can be a re-render, which is when that component's state updates. So that now React will call that component, that state, that change, and the output will be is a GSX. A GSX that contains this blueprint where it can contain is more React component. And if it is, it will continuously to call those components and repeat the process until there is no more React components in a recursive way. This is now developing this mental model here, okay? Developing this mental model here. Something that is very, 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 very important. Oh my God. Yeah, it is. Very, 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 very important. Oh, yes. Mm-hmm. 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 As you can see here, for subsequent renders, React will call the function component whose state updates trigger the render. And this process is recursive. If the updated component returns some of the components, React will render that component next, and if that component also returns something, it will render that component next, and so on and so on. The process will continue until there is no more nested components and React knows exactly what should be displaying on the screen. So after React passed through all of this, okay, now React knows what's to display on the screen. During the initial renders, React will create the DOM nodes for section H1 and H1. During a re-render, React will calculate with their which of their properties, if any, have changed since the previous render. It won't do anything with that information until the next step. But it's interesting because it not only goes to call that, okay, so React will calculate which of their property, if any, has changed since the previous rendering. Hey, is any of my property changed? All right. If it is, all right. Let me now store that information. Let me know that about this. Rendering must always be pure calculation. Same input, same outputs. It minds in its own business. Otherwise, you can encounter confusing bugs and unpredictable behavior as your code grows in complexity. When developing in strict mode, React calls each component's functions twice, which can help surface mistakes caused by impure functions. Optimizing performance. And this is when they mention is the default behavior of rendering all components nested with updated component is not optimal for performance. So if the update component is very high in the tree, you run into performance issue, and there are several opt-ins ways to solve it. Describing the performance section. Don't optimize prematurely. And then once React now trigger that change, so now when React detect that change in the trigger phase, and now it render that by looking at which components cause the states, it look at the component that cause the state updates that triggers the render. Okay, if it is the initial render, it's going to now put all of the elements there. And if it is caused by a re-render or by a re-renders, exactly, or for subsequent re-renders, it's going to now call these React components that cause that state's update to trigger the render, and the output for that, which is a JSX, if that contains React components, then it will call those components functions, check out for the properties. If they change, okay, all right, let me store that information for a moment, okay, and if that React components, which is a JSX, contains more of it is React components, it will do that process again until there is no more React components. So now React knows what to do. It walks through all of these three render data structure, or the tree render, okay, and then he say, okay, with all of these informations, all right, now I want you to commit the changes to the DOM, the commit phase, which is, all right, now let me look, okay, which is, now let me take a look at the, yes, okay, okay, good, which is, now let me take a look at the components here, and let me see which one of them are actually different. Which one of these, if there are any difference between render, if there are any difference between React components, and if it is, let me then apply the necessary updates to the DOM. So this is when we have these things like the virtual DOM and that kind of concepts. But again, the whole point of this is to develop that mental model of what's going on every time you set an update, you set an state. You're actually passing through all of these phases: the trigger, the renders, and the commit. And then on the commit, if that's happening in the initial render, React will use the append child done API and put all the nodes in there on the screen. But it's on the subsequence, it's going to apply only the bare minimum necessary, as long as the React components are different, as long as they are different between renderings. Okay, so that's interesting, because once the DOM is updated, okay, now the browser say, hey, something changed, now let me paint here. And this is the final step of that. So actually, here's the browser, when he detects that the DOM changed thanks to the React, it's like, okay, this is it. Show them to the user. So understand this, all right? And especially when you are going to now mutate this or set the state or trigger state change, it's also important to understand now how the states work as a way, it's pretty much like JavaScript variables, but it have a particular way to work with. You can think of this state as a snapshot, where setting the state will only be available, setting the state, when you set the state, setting the state, something that they mentioned here. Okay, setting a state only change it for the next render, exactly. And when do you set those state changes? It's on the event handlers, usually. Okay, it's on the event handlers, or on performing side effects, which is beyond the scope of today's video. But for our case, state only changed it for the next render. So even though that you trigger that, those states change will be reflected in the next render. All right. So as I mentioned, this state change can only happen is on the functions, on the handlers, on the event handlers. Okay, and the state variables never change within a render. Very important here. A state value never changes within a render. All right. So, for example, you can think of this, that React keep the state value fixed within one's render's event handler. So there's three concepts here. That is, the state value change is in the next render, and the state variable value never change within a render. Okay. In other words, you can think of this like React is saving. Okay, is keep the state value fixed within one's event handlers for that. However, if you want to now update your state before renders, okay, before re-renders, that's when we have now the in-queue or queuing series of states updates, which is this thing, right? So by looking now at the state as a snapshot, as a way to understand now how you can update this state change, and when this state change, you might think of this like JavaScript variable, but with a subtle difference. You can think of this as a snapshot. Okay, you set this state change, React detect that, apply the necessary change, and then give you a snapshot in the next render. Okay, so states variables never change or state variables value change in the next render, and you can think of that React is keeping fixed your React keeps this value. React keep the state value fixed within the once event, or within one of the renders event handlers. So what if you want, for example, now sending series of events before rendering? That's what we have, for example, in queuing state update, and how by now, for example, using arrow functions, you now have the ability to work with the states before you trigger a render, right? That's quite interesting. That's quite interesting. Setting a state variable will queue another render. But sometimes you might want to perform multiple operations on the value before queuing the next render. And to do this, it helps you to understand how React batches state update. So you can do like this, and what it's doing is that taking is the same state and then update it, which is 1, all right? Or this is pretty much like you're saying to React, hey, take all of these several orders and only get the last one here. Or if you want now to update the same state multiple times before the next render, you can do this by now is, for example, passing is an arrow function, okay, where you say, hey, I want you to now work with the previous value, okay, and then do that. You know, I want you to work with the previous value. So if you pass me a function here, okay, now let me work with the previous state to perform that before trigger a render. And a very interesting use case for that, you have this naming convention like this. It is common to name the updater function's argument by first letter of the corresponding state variable like this, and then trigger a render. If you prefer more verbose code, but again, this is you are actually is triggering is multiple state updates. So we also look at how can we now doing this and the logic behind this, which is you actually in any instance of this event handler, I fix the state value, which is you're gonna also use is this initially the 0 for this and 0 for that, and on the next render is when you're gonna update the state for that. So instead of doing that, okay, and if you want to now update sequence or queuing series of state updates, you can say, hey, I want you to now working here, pending here, like so. You say, hey, I want you to now work with the previous state, with the initial state, which is 0, and then return the new state for that. Okay, so then on the next state update, I want you to now work with the previous state that you have. Okay, and lastly, let's go now is to complete it here with that. So this is because we are now in our event handlers. Is not synchronous, is asynchronous. Okay, so we want to somehow preserve is the state of that operations and do something about that later. Okay, for example, It's actually quite weird for that. But it's actually counting all of that, right? Again, this is for very specific use case. And then we look at how can we now update our object state by returning always as a new state. How can we now updating a rate in a state by also returning is a new state, okay? And how can we now manage or update logic with immer in the most consistent way possible? That's what we use immer here. That's what we use immer here. That's the reason of why immer works. So how does immer works? The draft provided by immer is a special type of object called proxy that records what you do with it. This is why you can mutate it freely as much as you like. Under the hook, immer figuring out which part of the draft have been changed and produce a completely new object that contains you to it. Perhaps this might be quite overkill, okay? But immer what allows us to now use is this consist way of writing update logic here, which is now the next topic. Because now that we know, how can we add interactivity? How can we attach the event handlers to our template? Using a state as a way to now provide some interactivity or a components model as a way to now trigger some state updates. And what happened that is that React trigger in its own mechanism, which is the trigger, render, and commit phase. And what happened on each one of those phases, on the trigger, as a way to notify is, hey, who caused this state update? It was the initial render, or it was a component state update, or any of its ancestor. And the render is say, okay, now that I detect that, okay, what do I need to do? So do I need to actually look at it happened that on the initial render, okay? So do I need to actually call all of these components initially, or this section and that kind of thing, all of these HTML tag or React components, or it was caused in a re-render, which means is that React will know which components state updates trigger a rendering. It will call the component. That component returns you a GSX, and this GSX, if that contains React components, React will gonna call them, and if those returns more React components, it will repeat that process in a recursive way until there is no more React component. So once now he traversed to that render tree, React say, okay, now that I know this, it is time for me to it is time for me to go to the next phase. But before that, I want to know if any of these React components inputs actually are different, because that information is what I'm going to use on the commit phase as a way to say, hey, I'm going to now is apply the necessary DOM updates. If that causing the initial render, I'm going to call this the append DOM API, and then renders the entire UI, okay? But if this caused in a re-renders component, then I'm gonna see if there is a difference between renders. In other words, if there is a difference between React components, props, or state. If it is, all right, let me now apply the necessary DOM updates, the necessary DOM updates to that as a way to now update the DOM with the necessary change. And lastly, the epilogue is, all right, the browser detects those changes and say, all right, I need to actually paint this. So once we look at that, and then the reason of using is a state and understanding a state as a snapshot, as a way to understand how now this actually works, and your state's value updates is on the next render, and you can think of your state's value that React fix its value during the renders event handler, okay? And with that, now we can look at by triggering this update, okay? You can do that by triggering these updates in your event handlers. You can also not only trigger one update, but if you want to add series of updates, okay, or a sequence of updates, you can do that as well before the next render. And then you can handle that is, for example, handling is async operations, something that we're going to look at later, as well as how can we updating our objects and our arrays. Always use functions or methods that returns a new state that you can now pass to the state. It's a way to update the state logic, and because we need to find a way to make that consistent. Okay, now with the immer, it allows us to update the logic in a consistent way for objects and for arrays. So now we can think is on how can we now write our components as we grow and scale, because one of these main source of bugs is that relevant or redundant states, okay, as well as the rendering unnecessary. So before that, so we need to look at how can we now organize our states in our components and how our data flow will work. For that, it is something that actually Brian Hall described. Brian Hall mentioned is that, well, the way of how now you can is actually pass down data and that kind of thing is with a particular way. By using is now hooks and custom hooks, and how you can create your custom hooks in the more practical way. So here we're looking is now how can we managing our state as our application grows and scale. Okay, first by looking at that, how can we structure our state, how can we keep the state logic consistent and maintainable, the state update logic maintainable, and how can we now pass data between distinct components. So first thing first, for that, okay, for managing our state and to understand now how can we write our components in a way that can scale, okay, it is important for us to understand now what React provides for describing our UI. That, for example, before other solutions or without React, we have to manipulate our UI elements independently. So by describing is a different state that your component can be, this is similar of how now designers think about the UI. So first thing first is to look at how now the imperative approach compares to declarative. We're now in the imperative, especially when you are working directly with DOM in the JavaScript, you have to indicate each one of those elements. You need to indicate exactly, step by step, how you want to do this. There is nothing wrong with that. And in fact, this is something that I really like it because you have much more control about it. But this can become problematic, especially as you want to create or reuse some of this logic. So this declarative approach, which unlike the imperative, you can think of this like when you are in a taxi driver, when you are in a cab, taxi cab, you tell to your taxi driver, hey, go this and turn here and then turn around. You are telling them just in time. And the driver is quite nervous. Whereas now with the declarative approach, instead of actually telling how we want to go, we say, hey, this is the place I want to go. Find the best way for me to get there, right? Find the quickest pathway there. Okay. Okay. Good. 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 Oh shit, good. Yeah. So, with that, all right. Um, so with that, okay. So now, how can we use is the declarative approach with React, okay? What are the things, or what is the mental model that React say? Hey, if you want to manage your state, if you want to create now more complex application, okay, it is important to think of this in a declarative way. This is the mental model that React developers actually want to try to give it to you. And they say, hey, first, identify if your components states, or identify if your components identify your components different visual states, like so. Okay, identify your components different visual states, determine how those visual states, determine how trigger those visual states, okay, and then represent those states using an in-memory use states, eliminate redundant state that you don't need to, and then now connect your handlers to set the update state, okay, or to connect the event handler to set the state. And this process is something that you're gonna do over and over and over and over. So with this particular mental model, not only when it comes to create components, but also to detect those components, so you get the idea. you know, so you get the idea here. Yeah. So you get the idea. Pretty much is that. So svelte, let me see here, svelte, now you understand is the value proposition of svelte. You can now understand is the value proposition of svelte. Because at the end of the day, it's a compiler, all right, that allows you to now is write these components here as it is, SvelteKit. Just like that. Deploy anywhere. Render on the edge just for you. Learn pronunciation online with IPA. Photo management for teams. Trading strategy. And raster. A photo manager unlike any others. Okay, quite interesting. Like this, trading strategy as well. So I want to share your strategy here. It actually looks nice. It's now using Sphin. Holy hell. Redux, Svelte, and a kind of thing. Pigment, invite. In any case. Pigment. What is pigment? This is the home of pigment. It is a genetic syntax highlighter suitable for use in Go hosting. Go hosting, forums, wiki, and other applications that need predefined source code. Interesting. Okay. Anyway, but the idea here with React, specifically with React, is that hey, because we want is to now know how to create these maintainable React applications. Okay, we need to look at a way of how can we structure our state. How can we now look at a state update logic to make? How can we look a way to make our state update logic consistent, maintainable, and how can we now pass data to distinct components? All right. So here, by understanding is now the mental model of the UI, which is something that you can use this for your React performance. Okay, is that okay? First, identify your different visual states. Okay, then determine what trigger those states. Then represent is a state with then represent those states using the use state. Eliminate redundant logic for that, okay, or non-essential states, and lastly connect the event handler to set the state. And this is something that you're gonna do a lot of the time. The only subtle difference here is that which is now, because that's exactly what it's doing. This is exactly what we're doing here for any of the features. You know, any of the feature will ask us to do that. Period. Any of the feature will ask us to do that. All right, that makes a lot of sense. Okay, so now that we have this mental model, okay, identify the different visual states, determine what trigger those visual states, and then represent states in memory using use states, eliminate redundant or non-essential states, and lastly, well, connect to the event handler to set the state. Pretty much. It's like pretty much. We can also look at the challenge to do this as a way for doing that. Okay. And also with the profile editor, which is quite lengthy and verbose. Honestly, I don't want to do this. But again, it's like, hey, identify what are the different visual state. Okay. Pretty much with that feature. What are the different visual state? Okay. So visually, you should expect that clicking to the input picture, remove the purple background, remove that. and highlight the picture border. Clicking outside the picture highlights the background but remove the picture border highlight. Identify the different visual states. What caused and determine what caused those states change. Okay, what events or what caused those state change? In our case, on click, it can be not only human input but also can be computer interaction, the computer inputs. Okay, and that's now the challenge of choosing the state structure. So by looking now, this is now makes a lot of sense anytime I go through this. It's like now by looking at how it makes a lot of sense when you're creating your React components in a scalable way. So choosing the state structure here can make a difference between a component that is pleasant to modify and debug, and one that is constant source of bug. Okay, so here are some tips you should consider when structuring states. So, principle for structuring your states. Again, you can take a look at this anytime you're going to see a particular React component. You know, you can also actually having reference this topic here, choosing the states structure. Also, you can now apply all of these components as it is, okay, or all of these principles. It's like, hey, group related states, avoid contradiction. It's like if you have now several states that are updating in an event handler, or that is causing to check some similar conditions. Okay, so eliminate contradictions. Exactly, eliminate contradictions. Avoid contradictions. When the state is structured in a way that several pieces of state may contradict or disagree with each other, you leave room for mistakes. For example, when you're checking that. The other is avoid redundant state. If you can calculate some information from the component props or it is existing state variables during rendering, okay, you should not put that information into a component state. So when we are looking now at the avoid redundant state, is that, hey, can I get this information from its props or from its state variables? Can I get these props from its? Can I get this data or this information from its? Oh my God! Oh shit! Yeah. Can I get this data from its props or from its? Can I get this data from its prop or from its existing? Or from its existing states. Okay, so avoid redundant state. The other is avoid duplication in the state. When the same data is duplicated between multiple state variables or within nested object, it is difficult to keep them in sync. So for example, if you are now duplicating, or if you are now for some reason having several or subset of data in different states, please avoid that. Avoid redundant states or duplication states in this case. And the other is avoid deeply nested state. Oh my God, yeah, now it makes a lot of sense. Now it makes a lot of sense. So things are starting to click here. Holy French toast. Holy French toast. Okay. Now I want is to put a practice this. So now that I look is the reacting input to states, and how by managing our state, how can we now is reacted to input with state. Reacting to input with state. Exactly. Mm-hmm. 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 Reactive input with state. Exactly. Identify your components' different visual state. Determine what triggered those states change, whether it is a human interactions or a computer input. Okay. Uh, and then represent the states in memory with use state. So remove any non-essential variables, okay, and then connect the event handler to set the state. What is actually this documentation, this doc is giving to me and to everyone, is a mental model. We are now, they are trying to transfer this to others as a way to start to think in those terms, and I think that's quite interesting. And I think this is quite interesting. Mm-hmm. 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 Reacting input with states. And here when we look at the difference between now the UI, the imperative approach versus the declarative, why we go with the declarative, and why React promote, and how React promotes this thinking UI in a declarative way by looking at this series of steps and how you can react to this input with that. All right, so you can now identify the different visual states, determine what triggered those states, and represent those state change in memory with use state by eliminating its non-essential states, and then connect those event handlers to set the state. Now we look at the next topic, which is state structure. How can we now organizing our state in a way that is much more convenient, not only for ourselves but for others, in a way that is much more pleasant to change, to modify, or to edit, or debug. And that is, please group all of your states, group states, group related states. Avoid contradictions in your states. So if a particular state actually is contrary or is disagree with other states, please avoid this. Avoid this. That's why you need to have clarity, man. Clarity and decision making is very, very important. The other is avoid avoid contradictions, avoid redundant states, which is redundant state and duplication. In avoid redundant state is that, hey, this information that I'm getting, hey, can I get this data from its props or from its state values, right? Instead of creating a new state from that. This is avoid redundant. And the other is avoid duplication. Is like, instead of actually defining is a new state that depend of another state, all right? So avoid that. Do not use that. Avoid duplication, and also avoid deeply nested state, because it is very hard to update that. So avoid duplication in a state, it tells you that. So when the same data is duplicated between multiple states, which is what happened here, when the same data is duplicated between multiple states or within nested objects, it becomes hard to sync them. Mm-hmm. So the goal behind this is to make it state easy to update without introducing mistakes. Removing redundant and duplicate data from state, this is similar to how database engineers might want to normalize the database structure, to reduce the chance of bugs. To, Hey, we got the proper data and it's not duplicated. Mhm. So the challenge here is say, hey, um, because here you are using is this, avoid duplicating states. Avoid duplication in the states. So instead of doing this, okay, avoid duplication in a state. You can say, hey, um, use that directly from the props from that. Yep. Or also you can do something like this. Say color, color, like this. H1. Oh, okay. Now GSX is doing it. And because we're passing is an object, exactly. But again, it's like, well, say color. You remove this, and that's it. Just like that. You say props is not defined. Oh, okay. We don't need to get this time. So now, by eliminating or avoiding, eliminating is the duplicate state, which means that do not get the, do not create a new state from the props because it won't update that. Okay? So is this, but when the color prop change, does not affect the state variables, so they are out of sync. That's one of the reasons is like exactly. So avoid this. Look at this. Avoid this duplication. Avoid this duplication in the states, because especially here is not going to trigger that unless you specify that, say that. So by using now this, okay, reacting to input states, when those input change, now react now what to do with that. It is also interesting because React doesn't render its object here. React says, no, I'm not gonna render object here, for example, like color. That's quite sad. That's actually quite sad. So in React you can render objects, but you can render is no, you cannot, because you need to have is a root for that. But you can use, for example, render, for example, objects. Objects are not valid as React child. That's one of the reasons. That's one of the sad part that Vue actually allow you to do this. All right. The other is fix broken package list, and that to me was quite interesting. And this was quite interesting because you say this packaging list has a footer that shows how many items are packed, how many items they are overall. It seems to work at first, but it is buggy. For example, if you mark an item as packed and then delete it, the counter will not update it correctly. Fix the counter so it is always correct. is not updating correctly, which means that it's not able to sync that data. If not able to sync the data, perhaps we are assigning is this an perhaps this is assigned to a state. So for that, okay, for example, in the case of total, we say, hey, can we get this information from its props or for its current state? If it is, let's do it, man. Which is, hey, count total, okay, give me is the item dot length. Like so. So now when I delete that, of course, I didn't set that. It say, okay, set total is not defined, but we are not going to use set total, my friend. So we're not gonna use this set total here, right? So can we get this data from its props or for its states? If it is, good, do it. So you got it. Interesting. So it's not updating is the proper data here. So it's not updating is the proper data here. So it is not updating the proper data here. Items done length. Okay. Okay. Exactly, but it's also showing them properly. Okay. So it's length. It's actually updating that length properly. That's right. So far so good. The other is now this pack. Hey, when we are now setting, which is here, so for UI patterns like selections, keep ID or index in state instead of the object itself. So let's go to now is keep the index. All right, keep the index or in a state instead of the object itself. So here, one way we can do this is by setting is the index. Like so. We can say, hey, pack 0 is 1. Okay. And we can say is pack. All right. So can we now get this data here? So can we compute this data, or can we get this data from its props or its values? Yes. We can say is now comes back, okay, as a way to now filter for all of these elements, okay, whose item dot package are true, and then give me is the length for that. Items dot filter like so. Hey, if the item is actually packed, is the item packed is true? All right, give it to me. So I don't need to use this. And in fact, when I select this setback, okay, exactly. instead of when I actually said that, which is now on change, I'm going to now select that and do this, okay? And when I delete this, because I'm gonna remove that, now I can get this data in order. That's one of the beautiful things of this. When you're able to apply this basic stuff, these basic things, and then you can scale that up to solve these particular problems, things become way much more easy. So for example here, which is exactly that, is because, hey, can I use this information? Fix the disappearing selection, like so. Fix the disappearing selection. Oh, here. Again, fix the disappearing selection. Because we are now getting this data here, initial letters, okay? And they just stay here, okay? Anytime we click here, we want us to remove this. Avoid duplication in a state, and avoid deeply nested state. And avoid deeply nested states. And avoid deeply nested state. So for example, letter. Letter here is something that we're receiving from the handler over on hover from the letter, where now this is sending us is on toggle star on hover is the letter. So instead of actually setting that exactly, instead of actually using the object, okay, now we prefer to use is the ID for that. Highlight letter, set highlight letter, we can use in fact say is highlighted. In fact, we here, instead of say handle hover, say highlight letter ID, for example, letter ID, you know, following is what they mention is that when you need to update or when you have these UI patterns like selections, keep an ID or an index in state instead of the object itself. Keep an ID of the index instead of the object itself. So, for example here, keep an ID of the index instead of the handler itself. So here you're gonna say something like this, .id, you know? Another option here, instead of defining that as an state, is you say, because letters are gonna change, okay? And when we detect that change on handle hover, we would like to now trigger this. Okay, yeah, it has to be like this. Yeah, it has to be like this. It has to be like this. So when you have UI patterns like selections, instead of using the object, use the ID or an index. Similar to the implement multiple selections. Similar to implement multiple selections. So you can say select IDs and select IDs here, as a new set that will only hold, and I love it, this it will only hold values here, all right. And instead of actually putting is the selected count here, what you're gonna do is that when you handle toggle this, so on toggle, you want is to not only is check for those letters, okay, not only checks for those letters, not only set for those handlers here, but is to actually check them. But is to actually check them. In the case of the data here. Exactly. So here what you're gonna say is iterate through the letters. Okay. Letter.id. On checkbox is selected. Okay. Check that. Give you the ID. All right. So you're now holding is that ID. Okay. Holding that ID. Holding that ID, and then you're gonna. Oh, okay. Holding that ID and say, hey. So you can have now this data structure, this set, and say, hey, let's going to add this. If that exists, good. Exactly. If selected IDs. If this selected ID like this, right? If this selected ID dot hash is the toggle dot ID, then I want you to remove that from this. Selected ID does remove toggle ID. Otherwise, then add that. Selected IDs. Yeah, selected ID. Add toggle ID. Selected IDs. Oh, but you need to create exactly. You will need to create now a new state here, which is let's going to create a new state, which is next IDs. Okay, which is a new set. Remember that at the end of the day, anytime you want to set the state, you need to generate a new state out of this, whether it's an object or an array. After all, in JavaScript, everything is an object. That's why you have to do this. And then do something like this. If this select ID have this, you're gonna make this ID to the selected IDs. Okay. And then you're gonna ask that, hey, do we have that? If it is, remove it. If it's not, then add it. And then now commit the change. Commit the change here by saying next IDs. Okay? So now that you have these new snapshots, okay? exactly, this new snapshot, where now this contains all of the elements that is going to be rendered and selected, okay, and then is selected, all right, and if that is selected, what you're going to show now is exactly what you're gonna do is to say, hey, is this selected ID has the letter ID? Select count is not defined. Select count. What's select count? Selected count. You select selected count. Oh, and here we can say, hey, selected count. We can say this is like, hey, can I get this data from here? Yes, again, by saying is selected ID dot length dot size, because this is that. It's a toggle like this not defined. Oh my god, that's right. Okay, toggle it. That's right. And now it'll work as expected. Holy moly. Remove is not an option. No. How do you remove? Set in the end. Delete. Okay. Delete. Exactly. So now here we have now this mental model, especially when we're going to structure our state, okay, and we reuse the information for that, okay, and we reuse the information from that. So when you have UI patterns like selections, use ID instead of a use ID instead of use ID instead of an object, and use the set, because this is now much more faster than actually iterate through arrays, because now sets provide you is a linear time to access to this. So you can have as many elements as you want, okay? Selected count. Selected ID dot size. So when that changed, that change state also changed. So we in fact actually using some of this. All right, no problem. That was quite interesting. Totally interesting. So that'll be all for this video. Take care. Bye bye.